This is the physical sandbox, a facility that was made to perform the tracer experiments in order to simulate SATMAR experiences. We are now preparing the tracer for the tracer experiment. Maria José is waiting the samples or the tracer with the fertilizer, which corresponds more or less to 3 times what is advised in the box for the rice fields. So what we are trying to prepare, it's a concentration which is around 100 kilograms per hectare. Which gives a concentration of about 53 to 70 milligrams per liter. This tracer has the concentration that is usually used for the fertilization, and then we pick up these small pieces of fertilizer, and Tiago is smashing those in a portion of water. So we are spiking the samples in the previous day, so that tomorrow we start the experiment, and we have here the bottles with the tracer in it. These are the recipients for the water sampling, both in the Vadel zone and the saturated zone, and each sample has a bottle for the hydrocarbons and one for the major cations, ammonia, nitrogen, sulfate and bicarbonate. Using 500 liters tracer experiment that will be divided in these 20 bottles that are upstairs. This facility, which is built in LNEC facilities, was divided in 3 parts, A, B and C. And so these 3 compartments are made of the sand of Melides itself, in order to check out what is the reaction or the ability of the soil to retain the pollutants in the native soil. Then we have added a B experiment, in which we are using a layer of a mixture of the native sand with some organic layer. And finally, the 3rd box, which is built of 2 layers of soil, organic soil, in which we are testing the ability to retention. The retention of the tracer, which is a tracer made of the fertilizer itself, plus some hydrocarbons that are typically found in the rice field pads. We are installing in these layers Teflon cups in order to suck out the interstitial water. I'm climbing now the facility. We are coming up, and we can see here the 3 compartments that I was talking about. Each one has a piezometer and has 2 bottles one at 30 centimeters and the other one at 60 centimeters, in which we have installed a Teflon cup. We can see from the above the soil mixtured with the organic layer. Here it's the native soil, and now we can see the inflow of the water that is coming through here, and the sprinklers that are working and making a division of the water on the top, simulating type of irrigation.
We are now installing the CTD diver inside the piezometers. This CTD diver will measure the water height inside the piezometer, and it's installed at a height of 10 centimeters above the bottom of the piezometer. So this process is very simple.
This is the water inflow, and in which we can monitor the amount of water that it's getting into the physical sandbox, which is connected to the top, where we have seen the sprinklers working. So this is the other side of the area, and this one is the outflow. We are now having non-saturated conditions in the aquifer, and here it's like and this is a piezometer outside where we can measure the saturated column of water. At the moment we have no saturation, so it's all non-saturated experiment, but we will see along the experiment. Each piezometer has a sensor for conductivity, pH, redox conditions and the level, and we are sampling with a pump, a peristaltic pump, and the tube is always the same inside, and this is the pumping procedure. You can see the water flowing in through the tube. We are now collecting the water from the Vadou zone. So this one is from the 30 centimeters.
So now we are sampling the soil at two different depths, 30 centimeters and 60 centimeters.
Faltam as minhas luvas. Não faz mal. Ok. Agora já só mesmo com uma luz é que a gente lá vai.
Era uma gambiarrazinha, né? Vou ficar assim aqui.
60 certinhos.